I'm Eric, and in this video, I'm going to be going through a file system bug. It's a stack trace that we have from prod, and I have no idea what issue this is actually causing, what the user might be observing. It's just an exception being thrown that we need to investigate. I've covered up some sensitive information here, but everything that we need to debug the issue is visible. Um, so recording this video has a few purposes. One is file systems underdocumented. So by going through this bug, that will help us kind of look at the different pieces of file system and how they work together. Also, this bug might involve a race condition or some kind of stochastic behavior. So recording for me is really helpful to keep the observations straight, much more reliable than writing things down. So even if I wasn't recording this with the intention of perhaps uploading it, I'd be recording it for myself anyway, just so I can backtrack and see what's going on. So I think how I'm going to start is by explaining how I have my environment set up here. I have a screenshot of the stack trace and editor on the Pewter repo with nothing open yet, and as well as a draw.io window. So I'm going to be diagramming my observations here to kind of get a visual idea of the interactions between components if that turns out to be necessary. And we'll start by looking at this stack trace. Here we have a stack trace from production with sensitive information covered up. And the error message we have is that a required read failed. A required read is part of our database interface. When you call the required read function, you're providing an SQL query and you're expecting to get some information back. In this case, we're using MySQL Database Access Service. That's for our production deployment. And when we call required read on that, it will try to get the data from a read replica, and then failing that, it'll try to get the data from a primary. So it'll try everything it can, and then it'll throw an error if that data doesn't exist. So when you do a required read, it's an error if the data doesn't exist, and that's where this is coming from. This is related to Pewter's file system because we're trying to get a file system entry from the database. You could think of that like Pewter's concept of an inode in a Unix file system. So the question is, where are we expecting to find this file system entry? And then why isn't that file system entry there? I think the best way to proceed is to go to the bottom of the stack trace. I see event service here. I'm not sure if we're seeing the end of this trace because we have an event handler. That could be the reason why, or maybe just the limit of stack frames in the trace is here. That might be where the maximum is. But this is the information we have. Whoops. So we'll have to work with it. And this image viewer does this very annoying thing where it tries to thumbnail the video and loses my zoom setting. Anyway, so we're going to look at WS push service. That will tell us what kind of file system event is starting this to happen. Actually, we can see that here. It's on fs move. It looks to be the case. And then we're trying to get a safe entry. That's a client safe file system entry. So a file system entry that doesn't have anything we wouldn't want being sent to a browser. Then it looks like we do an ACL check. That makes sense because this is a file system node. We're going to check permissions and all that sort of thing. That's actually a lot of this trace because the permission service is a little complicated. Then we check if a node exists, which means we're going to fetch a file system entry. This is where we fetch the entry. Then we ask the file system provider to stat the file. So this is where we actually talk to the Pewter file system. Then we end up in database fs entry fetcher, which is responsible for talking to whatever database, be it MySQL or SQLite. It doesn't know, it's just using an interface to the database that has this required read method that I mentioned. And then it's trying to find a file system entry by UID, and that entry does not exist. So this could be a race condition where the file's removed while this is happening, perhaps, or it could be a completely different kind of issue. We have an optimization in the file system where if a file is being created and the FS entry is not yet in the database, we can take that file system entry from memory for some purpose. So basically we can pretend it exists already, and this optimization speeds things up an incredible amount because we're not making round trips to the database all the time. Instead, we're just working in memory off of what we've already done before anything's persisted in the database. So that's very important, but of course, it does lend some room for error, especially if this is going to the database when it shouldn't be, for example, instead of going to memory. So that's one theory I have of what this issue could be. But what I'm trying to do here is see if it can be guaranteed that that's not the case. I'm going to start going through these files and maybe diagramming them. Let's see how this goes. So I've got WS push service open right now, and we'll find that on line 159. Apparently I do look at my keyboard sometimes. I'm noticing this only now because I have this microphone in the way. Let's see. I need to be very home row keys oriented today. We're calling get safe entry on the moved FS node context. We can see FS node context is the next thing that gets called in the stack trace, and we're calling get safe entry. Let's take a look at get safe entry. If I can type get safe entry, oh, it was already here. This method will fetch an entry. You can tell that this is a kind of stateful method of FS node context because we await it, but we don't get return value from it. It's just going to populate this dot entry. We're going to check if whatever. Oh, we're going to set is safe on this entry. That will just let us check in other places and make sure that we got the file system entry from here, just to guarantee that we don't expose data that shouldn't be exposed. And then we proceed to clean some stuff up. Normalize some values, give the kind of more browser-friendly identifiers and the like, remove anything that needs to be removed. However, we don't need to worry about most of this. The error is occurring at fetch entry. We can tell this is happening on line, let's see, it says 771, which is, I am actually wrong. Am I wrong? FS node context 771. Okay, I confused myself because I was looking at a different stack trace earlier for an error that was very similar, but in this case, I don't remember what writable does. Let's find out. So this is going to be in 625 as where get is implemented. 625 is the ACL check. So this is happening during a permission check. But we are selecting an FS entry. I can tell by the way the query looks. I'm a bit surprised that we're doing that. Let's see permission service 105. I think that's the next place to check. (105). Okay, not 105. We need to go deeper. File system service 108. Oh, hey. That makes sense. Okay, we're checking if a node exists. Well, we're checking if we have permission to access that node. Let's see. The permission UID. So file system permissions typically have a UID. Right now, if you try to make a file path permission, so if you tried to give yourself fs colon slash something slash something slash read, what we do is we actually turn that into the UID. Eventually, we'll have to support path-based permissions when we have mount points because other file systems do not have a concept of a persistent ID that sticks with the file, right? You have the inode number, but say you use an editor like Vim, it's actually going to replace that inode so it doesn't persist. In Pewter, we have UIDs, so it makes sense for Pewter. Anyhow, so it does make sense that checking whether or not this node exists uh, could be the case that it doesn't exist, but it does not make sense that this results in a required read throwing an error, right? We are checking if the node exists because we want to know if it exists. That required read still means there is something wrong. We're expecting that the FS entry exists. So that means, presumably, we think the file exists. Or erroneously, we're doing something we should only do if we think the file exists when we don't think the file system exists. It's going to be something like that. Okay, so this information actually brings us back to FS node context because that's where exists is being called. All right, so method exists is going to be on 229, it looks like. So this is exists, and the first thing we do is fetch an entry. So 229 makes sense. That's where the error is coming from, right? We're fetching an entry. And then this is the, I mentioned I was looking at a similar issue. This is the point at which all of those issues converge is actually the call to fetch entry when we're fetching an entry. So the required read that is failing sometimes is related to fetch entry, which is great because that convergence also tells us whatever information we're missing from the stack trace when it was cut off probably isn't that important. It might provide useful context in what situation produces this error, but there's no guarantee that would be there anyway, right? It might be a previous action taken by the user or other operations happening around the same time from other users, just changing the way things get jumbled around in memory, so to speak. So yeah, uh, we have a pretty good indication that we have the information we need in this stack trace because of the convergence. All right, so let's look at fetch entry. It'd be really helpful if this image editor I had let me annotate this image like what FlameShot does, because I would like to mark what I've used and what I haven't, or what I've looked at and what I haven't. I'm looking for where fetch entry gets called. I'm struggling a little bit to find that, so I'm going to start back at 108. Uh, that tells me I might be in the wrong file. Oh, 108 was file system service, so sorry, 229. That's where fetch entry is called, and then 115. We are in. Oh, yes, this decorates all the methods. That's why we're seeing this in the trace. We decorate all the message. We decorate all the methods with tracer with a span, so that I can use this this thing. Wait, hang on. Um, software. I might be JAE or oh yeah, I spelled it wrong. This one? This one. It's so hard to find things when they all have the same name. This thing is very useful. Uh, I'll probably do a video um, on that at some point, just showing how we diagnose performance issues on Pewter. Anyhow, moving on. So this is also in line what I saw with the other stack trace. I'm in fetch entry, and I'm calling stat on the file system provider implementation, which is according to our stack trace here. Just zoom in there. That's going to be Pewter FS provider. It's always going to be Pewter FS provider when the issue is in the Pewter file system, so that makes sense. And that is throwing the error on line 126. 126 is the FS entry fetcher. And we're calling find on the FS entry fetcher. One thing that's of note is I believe on the other stack trace that I was looking at before, this is where we were seeing the error. It was on this get instead of find, which is a bit interesting. So that might indicate two separate issues. I'm not sure yet. So we're gonna start making some diagram here and getting a visual of the situation. Okay, so we know FS node context, fetch entry is involved somehow. It's always, the error is always produced under there. We know Pewter FS provider has a method called stat, and the issue is always happening under stat as well. We appear to have a divergence here, and I'm going to double check that looking through a couple of the stack traces, where we might call fs entry service.get, and we might call fs entry service.find. I'm going to clean this up a little bit, make it clearer. Okay, we have some arrows now. So we have fetch entry stat, and then depending on this, whether or not there's resource info, we either call get or we call find. And a bit of a hint of what this is doing is in this debug log here, where I say got an entry from the future. This is that optimization mentioned earlier. I might have mentioned, unless I end up deleting that clip. But anyway, just as a recap, that's getting an FS entry from memory that might not have been persisted in the database yet. So we know that we are writing this to the database. It's in a queue somewhere, and we might end up looking at that queue. And so we're actually grabbing it from the operation queue before it's written to the database so that we can move on and do other things while we're waiting on that. Otherwise, we'd have round trip latency affecting multiple different steps of, for example, recursive file system operations, which would slow things down by a great deal. So we need to do something like that. So this is where that happens. I just looked at some stack traces and I confirmed that it is sometimes line 123 and sometimes it's line 126. It does seem to be line 126 most of the time, but from my limited knowledge of statistics, what that tells me is I don't have enough data really to know for sure to say anything about the probability of these of one case versus the other. What I do know is both are happening, and that could be for a number of different reasons. One could be there's a common issue between these two cases, so either of these functions might have this exception become being thrown, and then we end up in stat, and then stat always throws the same error as a result. And the other possibility is these are two completely different issues that just have the same error message and both come from stat. Occam's razor would suggest the latter, that there's just one issue causing multiple pathways here maybe, but basically roughly the same issue. But I wouldn't count on that. My first theory was that the issue was always happening here because we're getting the resource info, but the entry is still not in memory. So this is the case when it's in memory, right? And maybe the entry is not still in memory, and then we end up fetching it from the database anyway, but it's not written yet. Some kind of erase condition there. And then for for the other case, where it actually should be written to the database, it could just be plain and simple race condition between different file system operations. Like a user deletes a file and then immediately tries to do something else that stats the file. That is absolutely possible. And I'm not sure to what extent we check for that. So there could very well be two different issues here causing something that looks very much like it's the same error. Okay, here's where we get deep into the weeds, and I'm even a bit nervous about trying to record the next bits of this because I am going to lose my train of thought. I'm just going to make incorrect conclusions while looking at things and then figure out that I'm wrong later, and this could be a mess, but we'll pull through it and see how this goes. So get resource info is our where we're diverging. Because sometimes we have resource info and then we're going to try to get an FS entry from the future, and other times we are going to do this find on FS entry fetcher. So what is FS entry service and FS entry fetcher? We have database FS entry service and database FS entry fetcher. Those are the only implementations. The reason why it's so specific, even though they're the only ones, is because we could use the decorator pattern here. It's a hint that it would be appropriate to do so, but there are no decorators right now. It's just these implementations. Database FS entry fetcher is a service, not a service. Yes, it is a service. It's a service that will fetch the entry from a database given a selector, whether it's a UID selector or something else when we call find. This will delegate to find by UID or find by path and such methods. Find name and parent, etc. FS entry service. It actually just uses FS entry fetcher to find the entry. Right, it delegates to FS entry fetcher. For this, it has some other operations like getting descendants or the size of a file, but it also has a queue of operations. These are operations that are going to affect the database, and we are able to look at that queue and get data from memory before FS entries are written, the optimization that I've been mentioning before. Get over here checks the queue, goes through operations, sees if there's a matching UUID. It only operates on UUIDs, whereas the find and FS entry fetcher operates on node selectors, which give you some options of how to find the files. Anytime we're pulling it from memory, though, it's because we have a UUID that we know that belongs to the file that's being written to the database, or the FS entry, I should say, that's being written to the database, because file could mean contents. Anyway, so we look at the queue, we try to find the operation, and then we apply. I don't know why apply is written here twice. That might be a bug, but this is sort of idempotent, so it doesn't really matter. I'll look into that later. And then we try to find the operations. Current state, I think it's the queue, or the in-queued operations that are currently being written. Deferred state is the queue that will become this queue when it's being written. Sort of like how if you're swapping frame buffers when you're rendering something in a game or something like that. In this case, we are kind of flipping between these arrays where one's the data that we're writing, and the next is where data piles up that's going to become that. And that's so that we can check operations in this current state. That's what that does. And then we do this find. So in the Occam's razor adherent case, the one where there's one issue causing the same error in these divergent branches, that would likely be in find, right? Because that's the one thing that's common between these. And indeed, the error is always coming from find. We know that because, well, let me see, is this one of the ones we're on to line 123 or whichever it was? I'm struggling to find that right now. Hang on. That was in FS entry or FS node context. No, computer FS provider. 126 or 123. This one was on line 126. Right, so this is the case where it's just find. I forgot what I was saying, actually. I'm going to go back and check. I could not figure out how to wrap up the statement that I started in the last clip, but anyhow, we're looking at a case where it's coming from find, and we did not have resource info. So what I'm looking at here then is not going to involve the possibility of a race condition related to getting the operation from memory, right? We're not even going through FS entry service in this case, which means this logic isn't happening. So trying to get something from memory and it's not there, that's not what's happening in this particular case. So we're looking at find. And we have a selector. And I guess we're assuming that the file exists. We are trying to stat it, right? So when we're statting it, we're assuming it exists. Now I need to backtrack a bit. This was from checking if an entry exists, wasn't it? We were doing a permission check, and that brought us to the permission implicator in file system service. And we're checking if it exists on line 108 there, which brings us to 229 in FS node context, which brought us to fetch entry, which brought us to 115, which is the wrapper for the tracer, which brought us to 116, where we call the original method, which brings us to 282, where we try to stat this entry. And it looks like we're expecting the entry to be null if the file doesn't exist. So I have a new theory now. Maybe this is a progression from when I started moving stat operations to the file system provider. What that would mean is I assumed a contract with stat that will get null FS entry when it doesn't exist, and that contract is broken by the fact that stat, in fact, will throw an error if it doesn't exist, which would, of course, be a problem. Let's see. So when we do a find, database FS entry fetcher, we are doing, let's see, that's not a required read, that's a read, but in find by UID, we're doing a require read. We're requiring that this exists. So, okay, that's an error. Going back to Pewter FS provider, in stat, interesting. So I'm going to compare this then with what exists does in FS node context. Actually, that's where this is coming from, isn't it? So exists might be broken. That would explain why this error seems to happen relatively frequently as of late. Entry exists. So the first thing we do is a fetch entry, which I think I've determined doesn't work. I'm going to do a quick local test. I'm just going to try to read a file or stat a file from pewter.js, so from the high level stat, and see what happens. All right, so I've got my local pewter instance here, and I'm going to stat this file by UUID. So that this should work fine because this file exists, but now I'm going to delete it. I'm going to delete it properly, so we're gonna, oops, we're gonna move it to trash. Why didn't that work? Okay, we've removed it to trash. I'm gonna empty trash. Okay, we have file or directory not found. Subject does not exist. And let's take a look at the server console and see what happened. In the server console, I have one alarm from an unrelated issue. It doesn't look like I got this same error here checking a file that doesn't exist. So maybe the high level stat isn't actually producing this error. So I'm going to check that. So stat, let's take a look first at what pewter.js actually calls. So it's going to be file system index. So this is in source pewter.js. So this is not backend, this is front end code. And when I called stat, let's see where that's implemented. I think up here somewhere. I actually don't see stat here. Stat is somewhere though. Let's look at the files. Operations, stat. Okay, here's stat. And we are calling the stat endpoint. So we're going back to backend code now. So these are in source backend, source routers file system API. That's the stat method. And we're calling HL stat. So file systems are organized into high-level operations and low-level operations. High-level operations are regression-safe implementations of file system operations based on what the client expects them to do. Low-level file system operations are more the ideal behavior of the file system. We might change how those work and then update the high-level operations to be non-breaking with those changes, or to not have been broken with those changes, I should say. So let's take a look at HL stat. So the first thing we do is we fetch an entry on the subject. So I actually would have expected to see that error. It makes it a little confusing that I haven't. So we are trying to fetch an entry for a file that doesn't exist, and we're not seeing that error. So there's something that I'm missing here. My assumption was that in fetch entry, right, we do the stat, and that stat is resulting in a required read because in pewter FS provider, that's indeed what it does. It calls find. It's not going to be calling this get, and then that find is doing the required read. Let's verify that we get here. Okay, I have a log there. We're gonna restart the server. I'm gonna wait for the pewter logo to pop up. There it is. All right, let's give that a try. So we get an error. We are inside the else and stat. We see that message, so that is happening. So I'm at least correct about that. So let's go into FS entry fetcher. Find by UID. I expect we're ending up here because I'm providing a UID. Okay, we are inside so this is going to be, we are in find by UID. That's what that is. We're going to restart the server again. Apparently, unconsciously, I look at my keyboard in my peripheral vision where the microphone's blocking it, so I'm screwing up a lot of keyboard presses right now, but let's see. We get in find by UID. So this is rather interesting. Okay, let's reload that. Try that again. Okay, I did that before the pewter logo popped up, so it's a bit difficult to see. So we're in there. FS entry is an array with no items in it. That's pretty interesting. So we have we get a list of rows is what happens, right? There are no rows. Require read is not failing. So where is require read? It's not in database FS entry service, which is where I just tried to get to it. It's an SQLite database access service. Okay, so this require read just calls read. So in development, we don't throw an error for this case, actually. So I should have reproduced the error, is what I'm seeing right now. But this error actually does only occur in the production environment because we're a bit more relaxed about require read and with the SQLite database access service, which is probably not what we should be doing. We should probably also fail here as well to keep it consistent. I'm going to take a quick look at the MySQL implementation, which I don't believe is in our open source repo, so I'm just going to end this video clip, take a look, and come back with my findings. All right, it looks like I'm correct. We do an explicit check to see if we got the data in the MySQL implementation, which makes us inconsistent with it, which isn't great. So that's the first thing I'm going to fix, is this. I'm going to make this also say required read failed. And I think based on the stack trace on the left here, I am outputting the query and the parameters. I'm just going to output the query in this case though. All right, and let's see. We have a required read. That will fail. Okay, so I'm going to wait for the pewter logo to pop up. There we are. So now we're ready to stat this file. Okay, internal server error. That's a little different than the 400 error. What's ironic about this is we were getting a 400 error saying subject does not exist previously, which is the correct behavior, at least from our perspective. But we were getting that for the wrong reasons. We should have failed faster than that on that specific 400 error. So that's what the crux of the issue seems to be. So if I go to the console, so actually this is not the 500 error I was looking for. Cannot read properties of undefined. Let's get some info about this alarm. I'm going to zoom into the console here because I'm not sure how many people in our community are aware of this feature. Terminal output gets a little scrambled when I resize it, but that aside, alarm, info, and then this says polite phone 4352. I'm going to write that. And we get a trace. So if you miss the trace in the output because it scrolls above too far, we can get it back because of the alarm service, which provides this to us. And we see this happens in find by ID, which is not where I expected that to happen, actually. We're probably not returning the results in what I just did. Yeah, we're not returning the results. If you noticed that earlier before I did, you get a gold star. All right, so now I'll do the test that I actually wanted to test. So we'll go here. Subject not exists is what we get. And I'm not seeing the error I expected to see still, which is interesting. Maybe results length is not 0, or maybe I'm not awaiting this and I should be. Apparently promise.length is not strict equal to 0. Well, that makes sense. It would strict equal to undefined. So I believe that's what was happening there. All right, waiting for the pewter logo. Okay, internal server error again. And this time, required read failed. That's perfect. That's what we wanted. And when I get the alarm info, no alarm with ID API error handler. Oh, I added the colon to it by accident. Yeah, so if I print out the stack trace of this error, we see it happens in stat, fs entry fetcher find, fs entry fetcher find by UID. So far, everything's pointing to my understanding of the problem. All right, fantastic. Just for fun, let's go to pewter.com. All right, so I'm loading my personal pewter account, and I'm going to make a file. There it is. I'm going to call it delete me. We'll get a UUID. This is the wrong DevTools. I'm going to open another one, which I hopefully remember to close before it confuses me and I use the wrong DevTools. Okay, so that's all good, and then we'll delete it and empty my trash. And okay, we get subject does not exist. We're not getting a 500 error in prod. That raises questions. All right, I'm gonna take a quick break and think about this for a bit. Maybe look around at some things and report back with my findings. I have with me the laptop computer from the background, and here's a funny thing about intuition. When I started to realize that the issue could be reproduced by stat, I thought, well, that can't be right. We would have caught that, right? We do a lot of testing. We do manual testing locally and in production, and we certainly would have caught a 500 error that always occurs when you call stat on a file that doesn't exist. That's something that we would have tested for. But we probably would have tested it on one of our production servers that reads and writes to the primary database. This laptop is on a different network, it has a different connection to the internet, and it's not hitting the server that we typically test on. It's hitting a server in uh, Europe somewhere. And I'm going to run the same call on here. And sure enough, what we'll see is 500 internal server error. I don't know if that will show up on the camera at all, but what this means is that we only throw the error when we're reading from a read replica. And that is the correct behavior. We're meant to be throwing an error there, but we didn't catch the other problem on top of it because of a different error in on the server that we usually test on. So this is a case of two things that are happening incorrectly that are sort of canceling each other out to result in the correct behavior in the environment that we're testing in. So with that new information, I'm pretty confident that I'm now reproducing the same error. And I also now know I need to fix the case when we're reading from a primary versus a read replica instead. But this needs to be fixed before I do that, otherwise it's going to cause more problems everywhere. So I've been thinking a bit more, and I think part of the reason this happened is the function that I actually want to call here doesn't exist. Uh, I don't want to require a read here, right? We're trying to find an FS entry, but if we don't have it, we should just report that we don't have it. But I do want to fall back to reading from the primary database if a read replica fails, which is a behavior that this function has, which read does not. So I need to go into base database access service here, and I think I need to add a new method. So first I'm going to move this over here because this looks like a sequence of different things now. And I'm going to make try hard read. Try hard read is going to have the fallback behavior, and require read is going to have the fallback behavior and require that results exist. So it's going to delegate to the try hard read implementation of the database service. And then over here where we do this check, we're not going to do this check. This check will actually be done in base database access service, which adheres better to the DRY principle. Don't repeat yourself. Instead of having our production MySQL implementation and the SQLite implementation in the open source repo both do their own check to see if there are results and throw an error, we'll do that here. And then the previous error that I found, the discrepancy between servers with 3D replicas and those without, would never have happened. So this is a much better place to do this check. We've got to make sure we remember to return results. And now, this will become the implementation over here. We'll just rename this. So in the SQLite implementation, this isn't really going to do anything different than read. So we could actually even just return that. It'll be no different with a database implementation with fallback behavior. This will do the fallback behavior. So if I reload everything now, Just wait for the pewter logo to show up. There we go. Flash there for a second. Alright, now I get subject does not exist, and I don't get a different error as a result of that. Oh, actually, no, I do. We get this dot required read is not a function. That's just because I screwed up somewhere. Let's see where I did that. Probably in here. Try hard read. Oh, yeah, look at that. Require read, right? It's called try hard read now. Alright, waiting for the pewter logo. Alright, let's see. We do have this SQLite health check failed. I'm going to check that out real quick. So, purple for 299. And that was, again, required read is not a function on line 274 of SQLite Database Access Service. Oh, is that 274? It was, yeah. That is happening. Oh, yeah, that's in the health check, isn't it? We can just do read here. Required read actually doesn't make a lot of sense. There, does it? Well, I can do this. We can't really require read in the same class properly anymore, right? Because I moved it into the base implementation as one of the sort of high-level methods. So it feels kind of wrong to call this here, but it will work. Let's see. Yes, and we do not have that error anymore. So what else could I do here? I think I'm gonna leave this here. I think it's probably okay to do this. No issue with it's coming to mind. It sort of defies the convention that I had, where these methods on the base class weren't actually meant to be used by a subclass. They're used by the user. Delegate to the implementation from the subclass, but in this case, we really want to do the higher level concept of whatever requiring a read is. So that makes sense. Well, with that, that is the entirety of the issue and solution and some interesting facts about our production environment. So hope this was enjoyable or helpful. And I'm gonna go start patching the prod version and testing it and seeing how that goes. Thanks again for watching.